classes. In the last video, we have studied about the second order system and its time response analysis. In this video, we will study about the time domain specifications. Okay, let's start our topic. Here, it is a time domain specification chapter. Here we have known this is a graph. In the x-axis, time is taken. In the y-axis, output C of t is taken. In this graph, by increasing with the time, the output changes continuously. But we have to study how this output is changes with respect to time. In this graph, we can study 5 important points. First one is delay time, next rise time, next peak time, then peak overshoot, and next settling time. We will study each term one by one. First, what is delay time? Now we go for the graph. In the delay time graph, it means as the time increases from 0 to some value, within this time, the output is also increases. If the output increment in the output from 0 to 100% and then in for a steady state value. For increasing from 0 to 100% for the first time, the time required to get its 50% value. If it is from 0 to 100% is this one, within this value, for the first time, the time taken for is 50% value. That means from 0 to TD. From 0 to TD, it is the 50% value. 0 to TD is known as delay time. Clear? So, what is delay time? Delay time means it is defined as the time taken to get the 50% of the output value for the very first time is known as delay time. So, 0 to TD is the delay time. Next, second point is rise time, that is TR. Rise time means in the same manner from 0 to 100% but very fast time. From 0 to 100% from this point to this point. To achieve this value for the very first time, the time required is from 0 to TR. This is the rise time. And this rise time is changes for the various systems. If the system is under damped, its value is different. Over damped, it is different. Critically damped, it is also different. So what is the value of TR for a under damped system? We know that what is an under damped system? Under damped system means 0 less than zeta less than 1. Within this value, the value of TR means the time taken to increase the value from 0% to 100% of final value. The time taken, the value from 0% to 100% for the very first time is known as rise time for under damped system. Similarly, for over damped system means zeta if greater than 1. If zeta is greater than 1, the time taken from 10% to 90% of final value. The time taken to reach from 10% to 90% of the final value is known as rise time for a over damped system. Similarly, for a critically damped system, critical damped means zeta is equal to 1. Here, TR the value varies from 5% to 95%. 5% to 95% of final value. That means from the signal for the very first time, it is this time taken from the 5% of final value to the 95% of a final value is known as this rise time for a critical damped system. Now the rise time is over. Next we go for the peak time. Peak time means if the signal from 0 to the maximum value. That means the time taken to reach the output signal from 0 to the peak value. From the peak value is time taken here, it is TP. TP from 0 to TP. The time taken to reach the peak value is known as peak time. Next, peak overshoot. Peak overshoot is a ratio. We'll study it here. Peak overshoot means first we have to study two important things. One is the value of output at maximum value, that is TP. It is the time for the peak time. At the time TP max peak time, the output value is C of TP. C of TP, this point is the output at maximum value, and another point is at time is equal to infinity, the output is equal to C of infinity, means it is the final value. So what is the peak overshoot? Peak overshoot is defined as the ratio. It is a ratio. In the upper, the value will be difference between the final value and peak value. That is difference between the peak value and final value with respect to final value. This is the peak overshoot. That means here we get peak overshoot is defined as the ratio between the output at maximum value minus output at final value with respect to the final value. This is the peak overshoot. And the last point is settling time. Settling time means the time required to the output to be settled. That means if the output is varying and it will got a particular value to stay within this limit, this is known as a settling time. So in this output limit, it must be having some error, but the allowable tolerance is 2% to 5%. So in the settling time, at T settling, in the T settling time, the allowable error at the output is 2% to 5%. It can be tolerant. So it is the tolerable error for a output signal. In today's class, we have studied the 5 important points for a time domain specification. That is delay time, rise time, peak overshoot and settling time by this particular graph. In this graph, in the x-axis time is taken, in the y-axis C of t or the output is taken in the time domain. So these are the 5 important parts for the time domain specifications. Thank you.